Hello again, folks, in 114. Today we're going to be covering section 7.4. This is the last section from chapter 7. Today is Thursday, June 10th. So 7.4 according to schedule, very good. And happy Thursday to you. Okay. Alright, the packet that I have for you today consists of this diagram. This is derived from two other diagrams. I kind of amalgamated them here. But the official name of this is dimensional analysis. I'm going to explain. Let's see. One thing is imperative. I would encourage you to print this especially, if nothing else. These two tables, because these are basically your list of conversion factors, all right, which you'll need to do anything in section 7.4. Basically, you'll be converting from the U.S. customary imperial system to metric and vice versa. And you need to know what equals what. What equals what. Okay. These are three particular word problems. They're the examples, but these are the three I want to look at. So I typed those. And then this is the information that is most imperative. If you just want to read these 2 pages, I stole these from the book and I just made them into a PDF. You'll probably be ahead of the game, all right? As long as you are familiar with this material. And then there are the actual examples with the work. All right, so you can look at that independently if you'd like. Okay. And I think that is good. All right, let me start with this. So if you're following along, do print that. And we'll get busy here. It takes 2 presses. I don't know why. All right, just the lights. Much nicer day than yesterday, very breezy. Can't have its throwbacks too. My curtain is going to move around. Alright, hopefully that will suffice. Alright, brightness. I think that's probably as good as it's going to get. Looks like it's aimed. And here's our page, but we just need to look at this. Alright. Back it off a little bit. There we go. You had a similar diagram when we started the chapter 7. And again, as I mentioned, I just adapted it to this purpose. The fancy way of saying that you would convert between different systems, all right, or I suppose within the same system, but between different units in the system. The fancy way of saying that is dimensional analysis. Okay, now what that would naturally employ then is conversion factors. Your book doesn't call them that, but I swear every other resource I've ever seen, we call them conversion factors. Anyhow, your book uses the phrase a unit fraction. Now, that is essentially taking things like this relationship. 12 inches is equal to 1 foot, and converting it into a ratio, as I mentioned. And you could stack them at will. You could put the 12 on top, you can put the 1 on top. Right? In this orientation, it would be referred to as a unit fraction. Why? Because look at what the denominator is. It's a 1. Sorry for the bit of the glare here. If I just move this, perhaps it'll be a little bit easier to see. Yeah, you see. Okay. essentially, usually when you have when you have a denominator of 1, right, you have a unit fraction. Right. Anyhow, I think a more general phrase that would be appropriate to use in place of that would be what I have been alluding to all this while, right? Conversion factors. It's the same thing, right? I tried to introduce this a long time ago. As a matter of fact, even when if you had me for 113, I brought it up even then, because it isn't any more complex to understand. Anyhow, this is the model that we will use in order to convert between the systems. Just to be cute, I suppose. All right. Let us call it the dimensional analysis machine. All right. It's an equation, but it's an equation model that you fit the appropriate information in here, here, and here. All right. So whatever you are given and whatever unit you are given, you would write it on the far left. Whatever you actually want, you will put on the far right, and that just at least the unit. And then you would choose, as long as you have at least one conversion factor that relates this unit to this unit, all right, you could situate the equivalents here and here respectively. Right. Basically, again, what does this allow you to do? It allows you to convert between different units and also between different systems in theory. All right, so a lot of times the conversion factors are somewhat rounded, all right, when you're converting between the metric system and the imperial system, because one is based upon 10 and another isn't. If you were just dealing with the metric system, you really wouldn't have to do that. There would be no rounding. You're just moving a decimal. Okay. Now, let's see. If necessary, you could add extra factors to get from here to there, right? Let me show you just to remind you. The diagram that I had given you yesterday, or the day before, and then misplaced it now. Oh, always when you want something, you lose it. There you go. Oh, here we go. Okay. If necessary, you could just adapt the model to include more conversion factors, right? I actually think that's kind of fun, really. Right? Just as an example, if you wanted to figure out how many fluid ounces there were in 1 gallon. Right? This is strictly the U.S. customary imperial system here. All right. The thing that's given to you would be here, 1 gallon. All right. And the thing that you want, so many fluid ounces, is abbreviated FLOZ, on the very far right. Now, if you look at the at conversion factors that you have available to you, unless you have it memorized, this particular one, as I'm kind of shooting from the hip here, doesn't have it. But if you look at the way back when we were in section 7.1, I had given you this photocopy from the inside of a marble notebook. All right, if you dig through here, all right, there are the conversion factors for liquid measurement in the United States. I'm reading it backwards, so it's a little bit tricky, but let's see. The closest that seems to be missing here. the closest, at least that I can see from just glancing at it right now, information would be this dry measurement here, where you see at least it says pints and quarts. Right, so I'll just give you the extra information just right now. All right. Pardon me. So many fluid ounces, you could work from the back here. If you want fluid ounces on the end, then fluid ounces must be on the end top here. All right. You could convert fluid ounces directly to cups, which is abbreviated as C. Right. There are 8 fluid ounces in 1 cup. Right. That isn't going to cancel this unit though. So if you want to cancel the unit of cups, you'd have to have the same unit essentially diagonal. So I'm going to put cups here and convert it to what I know from my childhood. Basically, 2 cups is a pint, PT. I don't know if that's faint or not. Looks like it's a little too faint to see, so I'm going to use blue again, reluctantly. A pint, 1 pint is 2 cups. All right, again, that's still not this unit that we would start with. But let's see. If you want to cancel pints, pints can be converted directly to quarts, which is abbreviated QT. And in 1 quart, there are 2 pints naturally. Still not quite the unit that we want, but unusually I'm working backwards this way. Quarts can be directly converted to gallons. So we will finally have this satisfaction of cross cancellation. Now, in 1 gallon, there are how many quarts? 4. Right? This is information that normally is provided, again, if not from the internet, then inside of a book. You know, the inside cover of a marble notebook used to have this information readily available. I'm surprised that photocopy didn't include it. Anyhow, 8 fluid ounces is 1 cup, 2 cups is 1 pint, 2 pints is 1 quart, 4 quarts is 1 gallon. The way that this machine, and this is an extreme example we have incorporate 1, 2, 3, 4 conversion factors, the way that this machine is rigged, if you think about it that way, it'll take us from where we are to where we want to go, right? And once you set it up, finally you get the satisfaction of canceling out stuff, right? Because you rigged it that way. Gallons cancels gallons, quarts cancels quarts, pints cancels pints, cups cancels cups, and you're left with the thing that you want, right, strategically. Now notice the bottoms here. Whatever you're given, you could always make it look like a fraction or a ratio would be more appropriate. Just stick a 1 through. If you're treating it as fractions, you know that it's brute force bottom times bottom times bottom times bottom. And if they're all 1s on the bottom, any 1 that you put here is totally superfluous. You don't have to do that. What you do end up having to do is top times top times top times top. And that will give you the answer that you're looking for. All right, so 1 times 4 is 4, 4 times 2 is 8, 8 times 2 is 16, and 16 times 8 is 100 something. 48, and 128. So if these calculations are correct, there are 128 fluid ounces in a gallon, right? Which would make sense, right? A half a gallon is famously 64 fluid ounces. So double that amount would be 128. Now I don't know if I have an actual gallon to verify here. Have a look. Sometimes the containers are deceptive. This one is legit, all right. Here is a container of cheapy orange juice in which you could see that they wrote 128 fluid ounces is 1 gallon. And this is the approximate in liters. So not quite 4 liters, it's 3.78. Right. So good work. The orange juice companies, they're getting stingier actually. If you, not that, I'm sure nobody wants to dwell upon it, but if you were to actually read the bottom of a Tropicana, what appears to be a half-gallon container, they're not 64 fluid ounces. They're usually just shy of that. All right. I think for the sake of the illusion that the price is stable at $3.99 a half gallon, whatever it is. All right. They just keep diminishing the amount of fluid ounces that they sell to you per container. It's something like 59, if not 54 now. Anyhow, what you see here is, again, the extreme case where you are converting via multiple conversion factors. But don't let that intimidate you. Again, as long as you have these individual factors in a table somewhere, right, they're the tools that you'll implement, and you're just doing it in a strategic way to cancel stuff, right? Almost on autopilot. It would be nice to just do it in one conversion factor, but sometimes the problems require multiple conversions. Okay. All right. I'm fighting with my curtain, so I better close the window. It's getting silly now. All right. As I mentioned earlier, what would be really useful to you when you're printing is this particular copy. This is anything that you would need for section 7.4 in my lab. Right. I will back it off in a moment. Let me clean up the gobbledygook here. This has a good amount of, there we go. Jeez, I should have just went for this to begin with. 1 foot, any American knows, is 12 inches, right? 1 yard is 3 feet. 1 mile is 5,280 feet. The only thing I would add to this is that you might find it convenient to also know how many yards there are. You could calculate that, but it's 1,760 yards is also the equivalent of 1 mile. 1 pound is 16 ounces, right? Which is not to be confused with fluid ounces. I mean, it is unfortunate that these have a similar name and even a similar abbreviation, OZ. Right? But these are fluid ounces. This is for the purposes of weight. Right? Fluid ounces is essentially a volume. Okay? So 1 pound is 16 ounces. 1 ton, that is TON, the imperial ton, is 2,000 pounds. Not to be confused with metric tons, which is 1,000 kilograms. All right. 1 cup is 8 fluid ounces, and a lot of times the abbreviation is just simply FLOZ for fluid ounces. Why the Z in a word that doesn't have that? It comes from Latin. And perhaps it has been corrupted over the centuries. The Wizard of Oz, actually, famously, the name Oz comes from ounces, right? Believe it or not. 1 pint is 2 cups, right? 1 quart is 2 pints, and 1 gallon is 4 quarts, and so forth. Okay? 2 cups. Let's see. All right. Then there is units for time. 60 seconds is a minute, 60 minutes is an hour, 24 hours is a day, approximately 365 days is a year. Okay? Now, these are things that are within the imperial system. Right? What you see on the opposite side here are the between conversion factors, that is from the US imperial system to metric and vice versa. And as you can see, these are not nice round numbers, a lot of them, they're decimals, and that really implies they've been rounded. 1 inch is really about 2.54 centimeters. All right, 1 foot is about 30 centimeters. 1 yard is about 0.9 meters. All right, 1 mile is about 1.6 kilometers, and so forth. All right, down here you have two-dimensional units. Remember, these are one-dimensional, these are two-dimensional. Notice the exponents of 2. All right, 1 square inch is about 6.5 square centimeters, would be appropriate to compare these. All right. Here's an acre and here's a hectare. All right. If you had 1 acre, it's a little less than a half a hectare. Okay. In the case of an acre and a hectare, because the unit is specifically for area, there is, and it's not derived from, at least not immediately, from one-dimensional units, 1 times the other. That's why it's not exponent of 2 here or here. And in this case, they're using HA as a hectare. Okay. Now, these are interesting. These are for cooking, right? 1 teaspoon is about 5 milliliters. Right. 1 tablespoon is 15 milliliters. I believe, actually, if you wanted to convert between these two, 3 teaspoons is about equal to 1 tablespoon. At least what I have looked up on the internet. Right? Just take that with a grain of salt. 1 fluid ounce is equal to about 30 milliliters. Right? Here's a cup, a pint, a quart, a gallon, respectively. And these would be in fractions or of a liter. Okay. A cubic foot. Now, if you're going to express, again, a volume using one-dimensional measurements, notice that the exponent is 3. That's from having multiplied the length times the width times the height, of course. All right, you could do that with a foot, you could do that with the yard per se, and the equivalents would be expressed in meters here. And then lastly, remember, weight and mass are not the same thing in spite of their similarity. Weight is dependent upon mass, which means that the more massive something is, yes, indeed, the more weight you'll have. They're proportionate, but they're not really the same concept. Weight is dependent upon gravity. Mass is the same no matter where you're standing. All right. Anyhow, 1 ounce is 28 grams. 1 pound is about a little less than a half a kilogram. 1 ton is about 9/10 of a metric ton. All right, capital T for imperial ton, lowercase t for metric ton, and the spelling is more. It seems more French to me. You could, if you wanted to, reverse the relationship. That's why you may say, well, aren't there different numbers involved here and here? If you had 1 whole kilogram, this would be about 2.2 pounds. All right, that's from the perspective of kilograms, a whole kilogram instead. All right, rather than from the perspective of a whole pound. Anyhow, all that you will do is take these at will and, where necessary, write them in the style of a ratio. So if it is convenient for you to write quarts on top, put 1 QT and 0.95 L on the bottom, or reverse them. Right? If it is more convenient in this arrangement, then you have the freedom to do that. That's the beauty of dimensional analysis, really. All right. So let's do some examples here. I'll put the light on. And I'll spare the bulb. what I'll do is, again, as I like to do, paraphrase some of these examples now. All right, the first one, let's do this. What would be technically example 1 in that packet is asking us to convert 26 ounces to so many pounds, lb. Remember, ounces is abbreviated OZ, and lb stands for libra pondo, so pound. I don't know why it's written that way, but so be it. Now, again, if you're going to stick with the model, green being faint would be actually apropos in this case. I'm going to superimpose the convenient information like so. Okay. What is given is 26 just regular standard ounces. So you would put that here, 26 OZ. Right. And pound is what you want. Right. And then you would look up in your table where you have one, if you have, in fact, a direct conversion factor, because again, there are some times when you may have to employ several in sequence. Indeed, if you sift through this, you will see that there is, in fact, a direct conversion. So that means that you only need one conversion factor. You will strategically rig ounces down here under the line here, and lb for pound above the line. All right. Do that with the units first always, because then that will force you to put the appropriate number here or here, respectively. In 1 pound, there are 16 ounces when we're talking about regular standard weight ounces. All right. Now that this little machine is rigged to go, you get the satisfaction of crossing out stuff. So the ounces cancels. That leaves you with the unit that you actually want. And if you want to, you could do a little simplification involving the figures 26 and 16 before you multiply, or do it after the fact. I'll do it both ways. If you were going to just do it brute force top times top as you would with any fraction, all right, it would be 26 times 1, which means you would have 26 above the line, and bottom times bottom, in which case you'd have 16 below the line. And yeah, you could basically simplify now, all right, whittle it down with rules of divisibility, or you could use your calculator to get the decimal equivalent. I'll do it both ways, as I said. It is a good practice, right, to attempt to simplify before you multiply. Why? Because it would make this task a little less arduous. If you, again, had several multiples, several factors to actually multiply, you may end up with very large, very outside the realm of familiar figures. So it is a good idea to try to simplify wherever it is possible. These are both even, so they're both divisible by 2 because they're both made of the number 2. That means that you could divide each of these to simplify by 2. So 16 divided by 2 is 8, and 26 divided by 2 is 13. All right, which means that you would have this 13 over 8 instead. The same relationship as 26 to 16 is 13 to 8. And now you could use your calculator or do the brute force division, as I will now. All right, the top figure goes inside the box, and the 8 is on the outside. How many 8s can you squeeze into 13? Well, roughly 1. And the difference is 5. All right. 8 goes into 50 roughly 6 times, which is 48, and the difference is 2. 8 goes into 20 roughly twice, and the difference is 4. And 8 terminates into 40 exactly 5 times. So essentially, 26 ounces is 1.625 pounds. All right. That makes sense, right? Because if 16 is 1 pound, and this is a little bit larger than 16, right? We would have a hefty fraction here, so 0.625, which is, what is that, 5/8, something like that? Here it is. 5 divided by 8, yeah. All right, so 1 5/8 pounds. Okay. I would argue that it's probably better to use the decimal, unless they tell you to round something. All right, if you want to preserve the precision, the degree of precision, all right, then don't round, use the fraction equivalent, which would be 1 5/8. Okay. I wrote a little note to myself, which is silly. 8, all right, pay attention to this, because when you're cooking, sometimes it's a little misleading, right? This is the standard that we have. Where is it? 1 cup is 8 fluid ounces. If you read something like a coffee pot, right, any of the instructions with your coffee maker, all right, they will say that it is 6 fluid ounces instead. Right? I can only assume that the reason for that is that they assume you're going to mix it with cream and sugar, so that will make up the difference of 2 ounces. But don't be fooled. 8 is an actual cup, not 6. All right. Now let's do some examples, and I'll go to my projection in this case. I took the examples and then I typed them myself at one point for the reason that I could emphasize certain things by changing color. I think that is a good habit. I mean, you can't, obviously as a teacher, you don't always give very limited time usually, but if you have the time, take the word problem that you're explaining to your students, enlarge it, you don't have to conform to the usual etiquette. You have to make it easy to dissect. That is more important. All right, and that's what I've tried to do here. You notice that this is not block indented or consistently the same color. Sometimes I change the size of things. All right, if you're trying to teach somebody how to decipher a word problem, make it as easy as possible, because you're not trying to teach them how to read at this point. You're teaching them how to translate. Right. Anyhow, on July 28th of 2014, when this problem was originally written, or about thereabouts, I want to see which one of these have I stolen this from. Let's see. This is adapted from example 2, so I'm calling it 1 here, but that's fine. On July 28th of 2014, the US dollar could be exchanged for 12.99 Mexican pesos. Right? Interestingly, the US dollar is symbolized by the S with the 2 lines through it, right? But pesos, my understanding is, uses the exact same symbol appropriately because they're both derived from the Spanish dollar. America is a very interesting mix of a lot of different things. Our language, of course, is English. Right? The primary, I would just say, it shouldn't be official. I don't think we have an official language. but we had, before being a colony of the British Empire at one point, by and large the people speak English, but our monetary system is derived from Spain, right? Our units of measurement are derived from, in some cases, go as far back as Roman times, if not Babylonian. And we're kind of an interesting mix of a lot of different things. Anyhow, the US dollar could be exchanged for this. The reason why the date is important is because exchange rates change every day. So this is what it was on July 28th of 2014, all right? What does that mean? It means that in theory, this was a conversion factor that might have been written this way. 1 US is equal to 12.99 Mexican, right? Or vice versa. You can't get away with using the dollar symbol because it's the same symbol in this case, right? So you're going to have to stick with words here. However, that is the this sort of equation style of writing the conversion factor, right? Without going any further, remember that if you were going to put it in the practical form, it would either be oriented like this or like this. So if you're reading it more or less intuitively the way I've written it here, left to right, then it would be 1 US is 12.99 Mex, or orient them as more like a unit fraction. 12.99 Mexican is 1 US. All right. Now, what will you do? Well, depending upon the question here, what is 2,500 pesos in US dollars? All right. Borrow the model given times the appropriate conversion factor. Sorry for the faintness, but it would be practical in this case. And this will spit out what you want. Let's just not make it a little too light. That one. Okay, so 2,500 pesos is what we're going to be converting from. So that I would identify as being given. Therefore, all right, you will put 2,500 here, and you could say pesos or Mexican dollars. Right. And then if you want US dollars, put the unit US here, the contrived unit. All right. Now, we will decide the orientation as either this orientation or this orientation, based upon what we have to cancel. We want to cancel out Mexican pesos. So what we will do is we'll put Mex here, and we'll put US here. So 1 US dollar is $12.99. And now you get the satisfaction of course canceling units. You can make that look like a fraction again. What you'd be ending up with here is 2,500 times 1, which is the same as just saying 2,500, and 1 times 12.99, which would be 12.99. Okay. I would enter this into our calculator at this point. 2,500 divided by 12.99, which would look something like this. Appropriately put that first because it's on top. And you see what the equivalent is. Looks like it's 192.45 or 46 if you round it. 192. Okay, this is about 192.455. And although it isn't specified in the problem, where does money end? Reason to yourself this much. We have pennies, right? Which would be hundredths of a dollar, which would basically be where this particular first 5 is sitting. So if we're going to round it, we might say $192.46. All right, those are the appropriate digits. Now, side note, although it has become in recent history a habit of people on the internet to put the dollar sign after the number, don't do that. All right, we've never done that, and we're never going to. All right, the dollar sign goes in the front, and here's the reason for that. All right, dollars are not something that you measure. They're something that you count, right? And even though this involves a number, all right, they're not, and you know, they would seem almost to be the same thing, they're not, right? There's counting and then there's measuring. Things that are counted, a unit of counting, a unit of money, which is counted, goes in the front, not in the back, right? If for whatever reason dollars was, you know, compared to some tool, all right, then I suppose it would be appropriate, all right? But there is no dollar counting tool to my knowledge. The card sharks are probably laughing at me right now. All right, here this is a counting machine, whatever. Anyhow, it's not the same thing. Measuring involves using an actual implement, all right, a standard to compare something to, all right? When you're counting, there's no counting. Even if you had a dollar bill that was like, you know, torn in half, one of the two halves is still considered one whole dollar, you know. You wouldn't say, oh, it's 50 cents. You don't do that. All right. Anyhow, so don't put the dollar sign here. All right. Put it in the front. All right. All signs are like that. If you've ever been to a gas station, you know that. All right. Please don't defy that. All right. It's just being lazy. All right. All right. Let's see. I'll come back to this and we'll do another one. Woof. Okay. Let's see. All right. Here's another example. This is example 3 officially, but again, I'm just paraphrasing here. You would essentially have to convert from 60 miles per hour to so many feet per second. Now, this is an example of something that is going to be multi-step, right? This is the way that you tend to see something in the United States on a street sign, MPH, the abbreviation. Let's write it out more verbally. Miles per hour. Okay. What are we going to convert miles to? We're going to convert miles to feet, and we're going to convert hours to seconds. All right, to satiate the question. So we're gonna, when we adapt the model of what is given times whatever conversion factor is going to be equal to what we want, it's going to be multi-step here. Right. You could do it as, you know, separate equations if you would prefer, but don't let it intimidate you either. Right? So let's see. I may have to do several of these. Probably going to need several of these. So I'm getting myself in trouble. Let's see how much we have. All right, start by writing on the very far left the thing that you are given. Write it in the style of a ratio, though. See how this is, again, an abbreviation, and this is it spelled out a little bit more clearly because it's more verbal than abbreviated. I would, conform to the standards of math world, which is that we have a ratio. So if it is 60 mph, therefore it is miles. Miles would be the unit that is above the line. And you can put the abbreviations for miles if you like. It's usually MI. Right, but it would be 60 MI, right? And then per is this line. Remember, per means divide. So a fraction bar style of division, and then 1 hour. Why 1? Because you can't have a 0 here. The most basic number you can have as the denominator is 1 itself. Okay, now, if you pay attention, you could start by converting to seconds, right? But just realize that on the end here, you want feet per second. Therefore, feet would have to be above the line. Per, again, is this line itself. And then seconds would be underneath it. There's a vague sort of equals in here somewhere, because I haven't decided how many of these conversion factors I need yet. It really depends on what I have to work with. All right, the tools in the toolbox. So just zero in on either of these, all right? And we'll go about the process of converting so that we land with the unit in the appropriate place. That is, if we're talking about unit of time, seconds, we need that to be a denominator. If we're talking about the unit of length, feet, then we need that to be more or less a numerator, top. Maybe we'll start with that because that's probably a little bit more intuitive. What can we convert miles to directly? I use red because it's a little bit easier to see. In a first conversion factor, if I want to cancel miles, then I could put miles down here. Use the abbreviation again, MI would be the appropriate abbreviation. All right. I have in my pile of conversion factors a direct conversion. Let me just point to it very quickly here. All right. If you notice what is available, 1 mile is 5,280 feet. So we do in fact have one direct conversion. So I could put miles here, I could put feet above the line. And since it's the end result of the cross cancellation would be feet above the line, you wouldn't even need to worry about it moving forward. Right? It's going to be where it's supposed to be. But the numbers involved are that in 1 mile there's 5,280 feet. Okay? Now, if you want, you can, yes, go ahead and do that directly, but I would try to rig the machine first. All right. Now, a second conversion factor, which I'll put adjacent here. What can we convert hours to? Being that hours is down here, all right, when we would rig the second conversion factor to cross cancel, it would have to be the opposite location. So, sorry for the glare. Or my shadow for that matter. Can't win. Just half and half there. Hours would have to be above the line. I know that there is this red obstruction that you see in between, but you don't have to really worry about it. All right, this is already going to be taken care of. All right, so it's in the way, but as long as these are factors, which means that they are things that are being multiplied are factors, so there's an x here for multiplication x, and a second one here, you don't have to worry about the stuff that is in between really. All right. So the unit that we need to cancel is going to go above for the sake of canceling this unit below. What can you convert hours to directly? All right. You can convert them directly to minutes. So I'm going to put MIN for minute. All right. that isn't going to take us to where we need to go quite all the way. If you want to, you could figure out a direct conversion factor of 1 hour to so many seconds, or you could do it in steps. That is why what I'm going to do is I'm going to rig a second conversion factor here for the sake of converting time that will address this issue of only having gone halfway, right? Having gone just so far as minutes is concerned. If minutes is down here, then minutes would have to end up being above the line here. And I know for sure that I can convert from minutes to seconds directly, so I'm going to put sec here just for the sake of conciseness. Okay, so it looks like I'm going to end up just needing 3 conversion factors in this particular case. So now I'm going to fill in the appropriate numbers. Once I have decided where the appropriate units will be for the sake of cancellation, then I apply the numbers that relate. So in 1 hour, there are 60 minutes naturally. And in 1 minute, coincidentally, thank you Babylonians, there are 60 seconds. Okay, so this machine is ready to run. All right. I'll just get rid of some gobbledygook. And we get the satisfaction of crossing out stuff. All right. Miles will be canceled by miles here. Feet will be left over on top. That's appropriate. Hours will be canceled by hours here. Minutes will be canceled by minutes here. Seconds will be left over on the bottom. That is appropriate. All right. All of the numbers are now where they're supposed to be, and we could just go about our process. If you want, do try to simplify first. Right? Try to simplify, again, before you multiply, only for the benefit of having smaller figures to deal with when you're trying to get to the answer at the end here. When you multiply things, what naturally happens usually is that they amplify. So before you dig yourself too big a hole, do the little bit of work that you can get away with before you multiply. Okay, so for example, an easy one is that there's a 60 here above the line, and I have a choice of either that 60 or this 60 to slash it with. All right, so how much slasher? 60 cancels this 60, leaves you with 1. All right, that leaves you with just one sole survivor of 60 here. All right, bottom times leftover 1 times 60 would leave you with a 60 down here. All right, this is a 1 behind as well for the cancellation effect. 1 times 5,280 times 1 times 1 would leave you with 5,280, and then you can pull even more tricks. Right? When you have a ratio of round numbers, as you see a 0 here and a 0 here, without really consciously thinking about it, a mental math skill that is handy is that you could divide by 10 in this situation without really consciously thinking about it. That is to say, cross out a pair of zeros. Right? If there were several pairs of zeros, you could continue. It's like dividing by different powers of 10 without thinking about it. That means that the numbers that you would end up having to divide are just these two. Right? If you're going to do it by hand. So 528, I'll put a decimal in here, and divide by 6. Right? 6 goes into 52 roughly 8 times, which is 48. The difference is 4. Short division. 6 goes into 48 exactly 8 times. Okay. And then it would terminate. So 60 miles per hour should in theory be 88 feet per second. Which is kind of cool. It's not 88 miles per hour, which you might be thinking, but no. What the hell is a gigawatt? Stupid references of me. Alright, anyhow. Where are we next? We're talking about blueberries yet? No. Alright, let's do converting between systems now, because this is really just playing with the US customary system. So another example is if you're converting, let's see which one did I steal this from, I'm curious now. Pounds to kilograms. Technically would be, I think 4. Yeah. This would be adapted from example 4. If you were asked to essentially convert from 353,000 pounds to so many kilograms, kg. All right, this is a simple one-step problem. So what you would do is write 353,000 over 1, if you like, LB times the appropriate conversion factor, which we do have a direct conversion factor, and that will spit out so many kilograms. This is essentially part A of example 4. The conversion factor that would be appropriate. If you look at this table, the one that you're given in the table, because there's 2 different perspectives of this, is down here. You could say that 1 pound, this is from the perspective of 1 whole pound, is a little less than a half of a kilogram. I think yesterday I gave you the other orientation. Right? 1 kilogram is about 2.2 pounds. It's true either way, but one is from the perspective of pounds and the other is from the perspective of kilograms. Anyhow, if you're going to cancel pounds, again, it would be appropriate to put LB down here and kg up here. And the relationship that we have established today, at least, is this. 1 pound is 0.45 kilograms. So in essence, since the denominators are just 1, you really don't even need to worry about it. You're just multiplying this number times this number. And in this case, you should get 158,850 kilograms. Okay. Now, if you follow the subsequent parts of this, B asks you to convert feet to meters. Um, 450 feet is equal to so many meters. Rig a machine, 400 is what you're given, feet is what you have here. You can convert so many feet to so many meters directly from the conversion factor choices. Let's see. If not, we will make it in 2 steps. Nope, we don't have a direct one. So what can we do? What we do have from our choices is that 1 foot is 30 centimeters, and then we'll just convert 30 centimeters into meters. All right, there's an afterthought. So you could use the diagram of the number line, the horizontal number line, once you get it to meters. But anyhow, we have something for direct conversion. 1 foot is about 30 centimeters. If we implement a second conversion factor, we can avoid drawing this line and converting from centimeters to meters that way. It isn't difficult, but you could. This is toggling in your mind a different way of looking at it. All right. 1 centimeter to cancel is so many meters, right? Or vice versa. 1 meter is 100 centimeters. So we could rig it that way, rather than when we get to this point, converting it via moving the decimal place. It's the same process. Anyhow, this machine is good to go. Feet would cancel feet, centimeters would cancel centimeters. You're left with meters, which is what it's asking. All right, it would be 1 times 1 times 100 if you did a brute force. Now again, I would simplify before I multiply. Notice that you have 100 below the line here, and you have a 400 above the line here. 2 zeros will cancel 2 zeros. All right, and it's just a 1. It's like dividing by 100 here and dividing by 100 here to cross simplify, but without really consciously thinking about it. Anyhow, the bottom line is that you have a 1 here. Right? And that leaves you with just 4 times 30, which is 120 times 1. So this is 120 meters is what you would end up with. Okay? Again, if you had gotten this far and converted to centimeters, you could always draw the number line. And then convert from centimeters to meters by moving a decimal point. Right, either is fine. This is just another way of doing it. All right. Oh, it's sticky today, isn't it? All right. Part C would be converting let's see, 700 cubic yards to so many cubic meters. All right. Let's look at our table to see if we have a direct converter. Let's see. We have in volume, I have to read it this way. Down at the bottom, we have these conversion factors. We have a cubic foot that we can convert to a cubic meter. Or we have a cubic yard that we can convert to a cubic meter. So we might employ these in addition to, say, something else. We'll look. All right. If we're given 700 cubic yards, I'm going to use the abbreviation. So yard with an exponent of 3 over 1. Hopefully I have a direct conversion, and if not, I'll do this in several steps, and that will spit out cubic meters. Right. This is what we're given, this is what we want. Essentially, it would have to be this relationship. Right. Meters on top, cubic meters, and cubic yards on the bottom. Right. According to the information that we have available, 1 cubic yard, although it's spelled out verbally, 1 cubic yard is 0.76 cubic meters. So we do have a direct conversion. All right. This cancels this. We're left with the unit we want. Ones are on the bottom. It's this times this. All right. You could reason to yourself that this is a magnitude of 100. So the effect of this is that the decimal is going to move over twice. And then it would be essentially 7 times 76. So let's see, 42, carry the 4. 49 plus 4 is 53. So you have 532 cubic meters. Just, you could verify with your calculator, but that would be the end result. Right. I basically, in my mind, I for the sake of efficiency, I looked at this as, well, it's 7 times 100. If you multiply by 100, a power of 10, that's the effect, right? That would accomplish that. Then you just have to do 7 times what's left over. Okay. D would be converting from square meters to square feet. So 648 meters squared is equal to so many square feet. So FT exponent of 2. If you write it as 648 meters squared, stick a 1 under it just to make it look like a fraction. The appropriate conversion factor, if there is one, would directly relate this to this, So if this is what we have and this is what we're given, they would go here and here, respectively. Feet squared and meters squared. Do we have a conversion factor that does that? I believe we do. Yes. All right. 1 square foot is 0.09 square meters. Okay. So 1 here and 0.09 here. All right. This would end up being, sorry for the mess, 648 over 0.09. You could divide it with your calculator, what have you, pull some tricks. You should end up with this, 7,200 feet squared. And then the last part of this would technically be E, would be to convert 1,900 liters, spelling it the American way, because I live here, equals gallons. Okay. 1,900 is what you're given, L over 1, times an appropriate conversion factor should give you so many gallons. Right? Again, if this is the unit you're given and this is what you want, then they would go here and here respectively. If there is a direct conversion factor already established, you can make one oftentimes. Let's see. 3.8 liters is 1 gallon. Which is interesting. I used to have a car that was defined as having a 3.8 liter engine, which means that it was using a gallon of fuel. It's actually terrible, but okay. That was its total volume of its cylinders. I suppose it was a gallon worth of fuel. If in fact you could, that's probably hydrolocking it, but man, that's quite an amount of space. Anyhow, this cancels this, all right? You're left with 1,900 divided by 3.8. And you should get about 500 gallons. In the context of the problem I took this from, it was example 4. I believe that's paint that they're talking about. Okay. Let me do those last 2 that I had, and then I'll stop. Okay, wake up. If blueberries cost $9, €9, which would look like this, in place of what we would have as a dollar sign per kilogram, what would they cost in US dollars per pound? Right? We have to convert euros to dollars, and then also we have to convert kilograms to pounds. So it's one of those multi-step dimensional analysis problems. All right, let's start with what we're given here. 9.00 euro, again, would be, since it's a counted unit, would be in the front. All right, per is this line, and it's per 1 kilogram, I would assume, so kg down here. The first conversion factor would look like this, right? It would just deal with one or the other. I would say start with the top. So if you want to cancel out euros and end up with dollars above the line, then dollars would have to be up here and euros would have to be down here. Right? This is one of those things that you would have to look up the daily exchange rate. I'm a ding dong and I didn't do that. Let's see. As of my birthday, as of March 6th of this year, 2021, this is the exchange rate. 1 euro equals 1.19 US dollars. Okay, so that is our conversion factor. All right. If we want dollars on top, 1.19 would have to be up here, and 1 euro would have to be down here. All right. Then in a second conversion factor, because again we're dealing with pounds, we have to exchange kilograms for pounds. So if kilograms starts out down here, we want kilograms above the line. And this is a measured unit, so remember where it goes in the back versus counted units go in the front. The pound we could put down here where it ends up appropriately. All right. 1 kilogram is about 2.2 pounds. From the perspective of this table, which is from the perspective of pounds instead, this is the relationship. 1 pound is 0.45 kilograms. Right? It isn't wrong to say that 1 is 2.2, it's just different perspectives. It's either standing here and talking about something or standing here and talking about something. All right? 1 unit versus another. All right, now this is rigged to go. Euro would be canceled by euro. Dollar would be left over, which is what we want above the line. Kilogram would cancel kilogram. Pound would be left over below the line. Right. It is down here 1 times 1 times 1, so you don't really need to worry about it per pound, 1 pound. And then it would be 9 times $1.19 times 0.45. Right. In which case, you should get this 4.8195. Now, seems to terminate there, I believe, but we're dealing with money. So where does money actually terminate? In the hundredths place. That is where the 1 is sitting. So based upon a 9 sitting here, what would we change this 1 to? About 2, right? So this is about 4.82 per pound. And my glue is dying, right? About $4.82 per pound. Right? At least as of this exchange rate from March 6th. Right? Okay. Alright, last thing. Drug dose problem. Let me clean this up. Drug dose is often administered according to a person's weight. For example, 30 milligrams for every kilogram of a person. If someone weighs 136 pounds, what would their dosage be? Right? It would be imperative in the nursing field, right? You wouldn't want to, you potentially could hurt somebody, or if you're not careful with the dosages. So let's discuss this. I'm going to rephrase this. Essentially, they're kind of implying a conversion factor here in green, which is why I wrote it that way. 30 milligrams is compared to, so I'm going to use the ratio symbol for just a moment. Maybe I'll just write it in a place where you can see it. 30 milligrams of the substance to 1 kilogram in the style of a ratio, right? Kind of can think of that as the traditional equals, just for this, for the time being. But anyhow, write it either like so: 30 mg over 1 kg for 1 kilogram for 30 milligrams. Okay, that's adapting what is in green here to something more meaningful in math world. Right, now, notice something. If someone weighs 136 pounds, we can't immediately use something that involves a kilogram. So that, without specifying it explicitly, we would have to reasonably, logically convert this to so many kilograms first. Okay, so let's rig a little machine down here. All right, so if we have 136 pounds, I'm going to disguise it as a fraction, so let's take a 100. And then I'm going to incorporate a conversion factor that is going to eliminate pounds, because what I actually need is kilograms. Okay. Next to it, I'm going to put a second conversion factor, which would be one of these orientations of the ratio of 30 to 1. So if I'm looking for a dosage, and the dosage is in milligrams, I want milligrams above the line, and I want kg below the line for kilograms. All right, now I'm going to fill in the numbers. Again, from the table that we have provided, 1 pound is 0.45 kilograms. And then this ratio, even though it's not true under ordinary circumstances, but for this particular problem, it's 30 to 1, we're converting. 1 kilogram is 30 milligrams, for all intents and purposes. Okay. Again, if you might be thinking, but that's not true, it's like magnitude of, 100,000 or a million, I forget offhand. This is, again, in the context of this problem, right? 30 to 1. So it really isn't appropriate to say that because it isn't really true. But if you use this symbol, we're saying that there's a ratio here. All right. Now you could simplify by canceling out. So pounds would appropriately be canceled here and here. Kilograms would be cross-canceled here and here. You just have ones on the bottom. The end result would be whatever 136 times 0.45 times 30 would be. That is your dosage in milligrams. So what does that end up being? 136 times 30 times 0.45. Let's see. $18.36. It should be 1,836 milligrams. I'm just going to verify because I don't want to kill the patient here. 136 times 0.45 times 30. Yes. Okay. 136 pound person times the ratio 0.45 times the ratio 30 gives you 1836. So 1,836 milligrams dosage. Okay. And I think that's it. Essentially what we've done here is even though this is, again, this is not true. 30 milligrams is not equal to that many, 1 kilogram. That's baloney. In the context of this problem, we have contrived a conversion factor. Isn't that cool? I think so. Right? You can do that. Right. It's just understood that this is not really, an actual measurement of mass. It's just how we would relate to a person. Okay, and that is that. All right, let me turn the light on. This off. We have finished. I'm trying to think if there's anything else to conclude here. No, I think that's it. Okay. All right. So we are finished. With this, just clean this up. I'm gonna have to really buff later. If you are following along according to the schedule for homework, in my lab, do section 7.4, and you are finished with chapter 4. Right. Just as a reminder, this is probably a little bit past the middle of the summer session. So if you haven't finished chapter 4, chapter 6, you really need to do that. I mean, the best advice I can give you, because when we get to chapter 8 and especially chapter 12, you don't even want to think about it, because usually chapter 12 statistics is a whole new ball game, right, for most people. All right, and it isn't difficult really, but it does take getting used to for the lack of familiarity. So please don't wait much longer. You really need to probably get on that this weekend. Okay, and thank you guys. I'll see you again on Monday. All right, be careful out there.